This video we're going to discuss area of some particular geometric figures. So to be specific, we'll look at the area of a rectangle, square, triangle, parallelogram, and trapezoid. The idea here is that I'm going to show you why the formulas are what the formulas are. If we can remember the whys behind it, it makes it easier to remember the formulas instead of just trying to blindly memorize them. But before we start talking about these specific shapes, I first want to spend some time talking about what area is and how we measure it. Okay, so I've drawn a very poorly drawn rectangle here. To just convince you it's a rectangle, I'll put little squares in the corner to say these are supposed to be 90 degrees. What we've talked about so far is measuring the perimeter of this rectangle. In other words, measuring the distance it would take, like if an ant were to crawl around the outside of my little rectangle here, what distance would it travel? That is a linear measurement because it's measuring length. Or I like to emphasize that it's a one-dimensional measurement. Alright, so if you think about like how we would measure that is we would take a ruler and just put it along the edge here. So if I had a ruler here, little tick marks on it, and I would measure how long that edge is, and I would do that for all the sides, and then I would add those up. So that's a linear measurement because I'm measuring along the side of something. That is not what area is. Area, on the other hand, is if I take my other poorly drawn rectangle here, put my little squares in the corner. Okay, so when I'm talking about area, I'm not talking about how long it'd take an ant to crawl around to that side. I'm talking about how much space on the page this is taking up. So when we're talking about area, we're thinking of things like wallpaper or carpet, or how much space does a sheet of paper take up on a desk, that sort of thing. So it's this space, this two-dimensional space. Now over here, I said that this was a linear measurement. The math word comparison for that for area is just area. It's a measurement of area of space it's going to take up. So when we're measuring I'm trying to teach you what the word area means, and using the word area, that's poor form, I get it, but that's what it's called. But the idea there is I can no longer use a ruler or a linear length to determine how much space something takes up, because now I'm working in two dimensions. So I need to measure this area using something that takes up area. So again, we're going to be measuring the two-dimensional space an object takes up, and so to do that we need a form of measurement that takes up two-dimensional space. So the idea there is to cut out a piece of something that is two-dimensional in nature and use that to measure how many of these it would take. So there's different ones of them, but I'll try to draw the best one I can here. Alright, so I drew a little green square there, and you're going to view this on different size screens, so this square will be different sizes, but I did try to make it the same length on each side. So what I was aiming for is 1 inch on this side. Now that is a linear measurement. It's 1 inch on that side, and then similarly it's 1 inch on this side. Okay, and all around, but we're not trying to determine the perimeter there. The idea is to have this square that's 1 inch on both sides, and so we call this a square inch because it's a square on each side, but and it's an inch on each side, but it's a square. So once we call this a square inch, this is our unit of measurement, a square inch. It's not something that is linear in nature, even though it's using the word inch. An inch is linear in nature. A square inch is two-dimensional in nature. It takes up area, and so what we're actually measuring when we measure area, if we're measuring in square inches, is how many of those it would take to fill the area. if we were measuring in square feet, we would be talking about how many square feet it would take to fill that area. So if you think of tiling a room and you have a tile that's 1 foot on each side, then you're going to have to fill that room up with a bunch of tiles. Well, if they're 1 foot on each side, the tile itself is a square foot. So the number of tiles it takes gives you the square footage of your room. That is the unit of measurement. It's not an inch. It's related to the inch in that that's the length of the side of each square, but it is not an inch. It is actually a two-dimensional thing because we're trying to measure in 2 dimensions. So here, if I wanted to figure out the area of my rectangle that I've highlighted here, I would essentially be tiling this rectangle and figuring out, these aren't square inches. We could imagine they are because everything's not to scale on my awful figures. But, you know, if that's a square centimeter, for example, and whatever size you look at it on your screen is going to be different regardless. But then when we're talking about the area of that, it's how many of these guys it takes to fill this space up, because that's what we're measuring by. And so if I declare this to be a centimeter on each side, then each one of those squares is a square centimeter. And so the area of this figure is 15 square centimeters. So that's what we're doing when we're finding areas. We're figuring out whatever our unit of measurement is. It's going to be something that takes up space, two-dimensional space, and we're figuring out how many of those it would take to fill up the space in consideration. So now that we have a sense of what we mean when we talk about measuring area, let's look at our different figures, starting with a rectangle. Alright, so I just moved the rectangle that I'd already drawn over, and assuming those are centimeters squared or square centimeters, then the area of this rectangle would equal 15 centimeters squared. But when we're trying to figure out area, we don't want to actually have to tile it to figure it out. So we can use the power of multiplication here, because if I have 3 rows and each one of them, alright, my highlighting's not working, it's all coming out to be the same color, so I'll do this. I have this row, and I have this row, and I have this row. Each one of those are 5 tiles. Well, we could think of that as saying, okay, well, my area is going to be 5 plus 5 plus 5, but if it's squared out like that, and I use the word square to mean that they're all right angles in the corners, then it's always going to be the same number added up over and over again, which is why multiplication exists. So this is actually just 5 3 times, or 5 times 3. Of course, you could write it 3 times 5 as well. But the idea there is, if I call this my length, and I call this my width, then my area of a rectangle is always going to be taking the length times the width, because it's always going to be equal amounts of squares. Now, the squares won't always be equal. So, for example, I could have cut my rectangle off right here, and then I have like a half square centimeter down there towards the end, but it's still the same. When I say it's equal, it's the same number of squares in every row. So the length times the width would tell you how many total ones you have, because multiplication is fast addition and addition is fast counting. And all we're doing is counting up how many of those square inches it would take to fill up that space. And so this formula here is going to be the formula for the area of a rectangle. So the area of the rectangle is determined by determining what the length is, what the width is, multiplying them together. Hopefully that makes sense to you, so you're not just memorizing a formula, but you're seeing, hey, why that works. Okay, now next we have on our list of ones I said we were going to cover is a square. Now if I take this figure I have right here and just look at like this piece, it's a square, right? And a square is a rectangle. So the way you find the area of a square is the exact same way you would find the area of a rectangle. The difference is that a square is always going to have the same length and width. And so oftentimes they give you a different formula for that, but it's the same formula just with the same length and width. Because if the length and width are the same, I can actually multiply them together and make it s squared. I hesitate to give you this formula at all because it's completely unnecessary. You can always use the rectangle formula to find the area of a square because a square is a rectangle. And I don't even like thinking of the rectangle formula as a formula, but going back to the concept of figuring out how many tiles it takes, and so I need to multiply the number of tiles along the length times the number of tiles along the width, and that'll give me the total number of tiles because that's how multiplication works. Alright, so that's rectangle and square. The next one on our list was a triangle. So let me clear out the screen so we can talk about triangles.